the study guide for Algebra B, Test 5 of Quarter 3. And so this test is testing us on different ways to solve a quadratic. And one of those ways is by graphing. And so that's what we're going to do on this first problem here. So the first thing you're going to want to do is find that vertex. So we use this axis of symmetry formula, negative b over 2a. So our a term is the number out in front of x squared. It's 1. The b term is the negative 2. And the c term is the constant, negative 3. And so we're going to just go ahead and substitute those numbers in there. So it's the opposite of b, so it becomes positive 2 over 2 times 1 just makes 2. So you're going to take that value, and this is our x value. This equals x right here, the x value of the vertex. And we're going to take that 2 and plug it in for these x's right here to solve for the y value. And so we'll write down y equals, and then I've got 2 squared. Now actually it shouldn't be 2, it should be 1. So let's go ahead and fix that real quick. So 2 divided by the 2 makes 1. So I'm going to end up with 1 squared. 1 squared minus 2 times by 1 minus 3. And so when I square the 1, I get 1. 2 times 1 makes 2, and minus 3. So I go ahead and do a little bit more work there. I've got y equals negative 1. And again, you know you're doing something right when you find this vertex, the y component of the vertex, if these are opposite in sign, the first two terms, and one is double the other. And so we have that situation, if we ignore the negative sign, that is. And we go ahead and do some work there, we get negative 4. So our x value is 1, y value is negative 4. And this is just the vertex. We did all that work just to find one point. But from there it goes really fast. So over 1 down 1, 2, 3, 4 spaces. And then from there we use the parent graph. In this case our parent graph is just an x squared. So if you square 1, you end up getting 1. But you always go from vertex, from the vertex. And so from the vertex, if I go in the x direction 1 space, I go up 1 space. And we end up crossing the y-axis right here, and that should match what I have in my equation. Negative 3, the c term is the y-intercept, and that's the case. So the next one I'm going to plug in there is 2. So I'm going to go in the x direction 2 spaces from the vertex. Well, I square 2 because that's what it says to do, and I go in the y direction 4 spaces. So over 2, up 1, 2, 3, 4, and I end up right on that axis, the x-axis, and that's what I want. I want these points. I want this point here, which is negative 1, this point here, which is positive 3, and that is our graph, our quadratic, and those are our answers right there, negative 1 and 3. Well, the next problem is going to be a little different because it's not going to have x squared as the a term. A term is a little different. It's just a 1/2. B term is 2 in this case. No c term. C is 0. So this is c value here is 0. And this all again equals y. And we're going to figure out what the x-intercepts are. So we're going to end up setting it, that y value, equal to 0 eventually. So let's find that axis of symmetry first. Negative b over 2a. So I substitute in. I've got opposite of b is negative 2 over 2 times by 1/2, which makes 1. So that just makes negative 2. So negative 2 is the number I'm going to put in for x there to find out what y is. Well, I'll go ahead and do some work. Again, what I should get when I do this, when I plug in the negative 2, is I will end up with one term being positive, one term being negative, and they'll be opposite. The one will be double the other, ignoring the negative sign, that is. So here I end up with, let's see here, I square the 2, and I end up getting 4, and 4 times by 1/2 gives me 2. And that's positive 2, and here is where I get my negative value. Negative 4 is what I get when I multiply the 2 times the negative 2. So there I have it. Opposite signs, one's double the other, ignoring the negative sign. So y equals negative 2. So there's my vertex. Negative 2 comma negative 2. So I go 2 spaces to the left, 2 spaces down. There's my point. Now I'm going to use the parent graph. Parent graph's the y equals 1/2 x squared. So all y equal 1/2 x squared look the same. They're just different spots. The vertex is always in a different spot. So I'm going to go ahead and square 1. So I'll go in the x direction 1 space over. Now let's see how much I'm going to end up going in the y direction, because I have to times by 1/2 after I square the 1, and I just get 1/2. So over 1, up 1/2 space. That's it, just 1/2 a space. Well, if I square 2, I get 4. But then I've got to take half of that, and that gives me 2. So over 2 spaces brings me up 4 spaces. Or, I'm sorry, brings me up 2 spaces. And that gives me my 2 answers there. So over 2, up 2, over 2, up 2 is what we ended up doing. So we ended up getting 0 as 1 and negative 4 as the other intercept. And so there it is, negative 4 and 0 are the two x-intercepts. Well, taking a look at the next one, this one says to solve by factoring. Whenever I factor, I'll need to move the constant back to the other side in this case, because I always need to set it equal to 0. And that's what I did here. And so now I'm going to look for numbers that multiply to make 4, but they're going to end up adding to make the negative 5. Since they add to make a negative, it means they both need to be the same sign, obviously, because they multiply to make a positive, but they need to add to make a negative. So I'm going to put negative 1 here, and x minus 4 here, because you see these multiply to make a positive 4, but I check the addition, negative 4x, negative 1x, those add to make negative 5x, so it works. Well, we just take those two factors and we set them equal to 0, and then we solve. And so we're just doing opposite operations here. I'm adding 1, here I'm adding 4, and we'll end up with our answer. We get positive 1, and we get a positive 4. So the two x-intercepts. Looking at this next one, it's another factoring problem, a little bit tougher one here because we've got a 15x squared, but it's all set up for factoring because it's set equal to 0. But instead of starting with the x squared term, I'm going to start with the constant 3 because there's only two numbers that multiply to make 3. It's going to be 1 and 3. So now I just need to figure out what numbers multiply to make 15x squared. I know the outside and inside terms are going to subtract to make 4 because the last term is negative. That means they have to be opposite in sign. So my guess is that I'm going to end up with like a 3x and a 5x in this fashion because, see, this will make 9x. I needed to make something a little bit bigger than 4, and then here I had 5x, and these will subtract to make 4x, so it does end up working. In order to make the positive 4, I'm going to put the negative, or the positive sign with the 9 and the negative sign with the 5. So there's my minus sign, there's my plus sign. Once you're sure the factoring's done right, because that's important, if it's not, your answer is going to be wrong. We're going to go ahead and take the two factors and set them equal to 0. Remember to do this step, because this is a common mistake. Some people just want to add 1 and they say, oh, the answer's 1. Well, no, not quite, because 3x equals 1. So you have to divide by 3, and you get yourself a fraction there. 1/3 is the answer. Here we have to subtract the 3 from all sides, and I end up with this 5x equals negative 3. Divide by 5, and we get the other answer. So 1/3 and negative 3/5 is the two answers that we'll end up getting there. Well, looking at the next one, we have a different method now. So the different method is completing the square. And so when we complete the square, remember you always want to have the ax squared and the bx term on one side, the constant on the other side. So here I have to move this 2x back to the left-hand side. So I end up with this, x squared minus 2x, leave a little bit of a gap, equals 6, because you're going to end up wanting to complete the square. That's the whole idea. That's why it's called that. So we want to figure out what two numbers add to make negative 2. So what you end up doing is you end up taking negative 2 and cutting it in half. And that gives me negative 1. But then from there, you got to square that. Well, that just is 1. So that's the number that you're going to end up adding to both sides. I'm going to end up putting a plus 1 here and a plus 1 here. It's real important to make sure you add 1 to this right-hand side because that's the number that's going to change. This trinomial, the whole idea behind that was just to get that factored form that has a quantity being squared, and that's what we have here. X minus 1 quantity squared equals. Now again, the way I get that is whatever half the b term is going to go inside the parentheses. This term right there, that's got to go inside the parentheses because those are the two numbers, negative 1 and negative 1. They add to make negative 2. They multiply to make positive 1. So that's why that goes there. Anyhow, this quantity being squared equals now 7. How did I get 7? Well, I added these two numbers, 6 and 1. That's why it's make sure you add that 1 to the right-hand side. It's real important. Well, from this point, I'll just take the square root of both sides, and that will cancel out that squared symbol, leaving me just with this x minus 1 equals plus or minus the square root of 7. So the last step here is just to move that 1 back to the other side. So I end up having to add that 1 to all sides, and the 1 to this side. Well, you can't add 1 to the right-hand side. You can't add 1 to the 7, that is. So you're just going to have to leave them separate. So your answer is going to be 1 plus or minus the square root of 7. And there it is. Well, let's take a look at the last one. It's another completing the square problem. There's 2 steps that you got to do before you start to complete the square. And that's to first move this 12 over. So I'll go ahead and add the 12. And so my first step, second step I guess, is 2a squared minus 5a equals 12. Well, the next thing we've got to do is we need to get rid of that 2 that's in front of the a squared term. So I'm going to end up dividing this entire thing by 2. And so what's left over? Well, we now have an a squared minus 5 halves a, and this all equals 6. So again, we're taking this 5 halves, negative 5 halves, and we are finding out what 2 numbers add to make that. Well, that means you're going to multiply it by a half. That gives me negative 5 fourths. All you're going to do is take that negative 5 fourths, and you're going to square that number. So that gives me 25 sixteenths. So 25 sixteenths, that's what you end up having to add to both sides. So we're going to go plus 25 sixteenths here. That makes this a perfect square trinomial, and over here, 25 sixteenths. So the whole idea is to come up with a perfect square so that you can take the square root afterwards. So now we have the factor form, a, and it should be a minus sign, so let me fix that. A minus 5 fourths. Again, it's whatever we get for half our b term. So I'm going to make that a little more clear there. And so half our b term was right here. And so that's the number that goes inside the parentheses. And this all equals. Now off to the side, you're going to end up wanting to add these numbers here. And so we've got to come up with that common denominator, multiply the 16 by the 1, the 16 by the 6. So we come up with 16 as the denominator there. So 96 is what we get there. 96 sixteenths plus 25 sixteenths, and that makes 121 sixteenths. And so that's what we have on this side. Well, from there we're almost done. We just need to take the square root. And once you take the square root, we're going to end up with 2 numbers on the right-hand side. We've got this a minus 5 fourths equals plus or minus 11 fourths, because take the square root of 121, it is 11. The square root of 16 is 4. From that point, all you've got are 2 steps there. You just got 2 processes. You got to move this 5 fourths to the other side. So we'll go ahead and add that 5 fourths to both sides. And we got 2 problems to set up. We've got this 11 plus 5 over 4, and we also have this negative 11 plus 5 over 4. So we go ahead and do a little more work. When we add these, we end up with 16 fourths, which makes 4. Over here, we end up with a negative 6 fourths, which gives me negative 3 over 2. Those are the 2 x-intercepts. Well, check out part 2 for the last 3 problems.